Hey y'all, we are Memphis Community University and we are back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today we are going to be continuing our integration journey. We are going to be learning integration by parts. So, integration by parts, if you don't know, is a BC topic only. It does not appear on the AB exam, but if you're taking AB, you can certainly join and enjoy the fun. For college calculus exams, integration by parts does appear in college calculus 2 exams generally. So just like with U-subs that we learned previously, what U-subs did was change a harder integral into an easier integral in terms of U. This is the same thing. Unfortunately, integration by parts doesn't give you the answer straight up. It'll turn a harder integral into an easier integral using some sort of process. Keep in mind that throughout this process, you might have to U-sub, you might have to dig basic antiderivatives. So I would highly encourage you to watch our basic integral videos, our indefinite U-sub videos, definite U-sub videos, AB integral videos as well, where we talked about easy U-sub and skipping the U-subs, because all of those things will come into play as we do integration by parts. That's why people learn integration by parts after you use U-subs, because again, sometimes they incorporate U-subs. So watch those U-sub videos if you want to be comfortable with this. This video is going to be on indefinite integration by parts. If you watch this video and you enjoy it and you watch the next one, that'll be on general integration by parts as well as definite integration by parts. But let's get started. So the chain rule is the opposite of U-subs. This is product rule because integration by parts is the opposite of product rule. So let's get started. So first let's talk about the formula for integration by parts. So integration by parts, how fun. Once you start getting through this formula, you might actually think it's easier than U-subs, but this is the formula for integration by parts. It's going to be the integral of u times dv. So I'll tell you what I mean by u and times dv. It's uv minus the integral of v du. So again, what we're going to do is we're going to have this integral that we're going to start off with, and hopefully we'll convert it into an easier integral. And then we still have to take this antiderivative eventually. So this integral might be another part, might be U-sub, might be just straight up, we know the antiderivative. So keep in mind that what's going to happen is that both u and dv is going to be in terms of x's, and we're going to choose some things to be u, choose some of the things to be dv, just like we do with u-subs. Let me try to distinguish between my u's and v's. I don't know why books use u and v, sort of the worst letter to choose, but that's the normal convention, so I'm going to stick with it. Once we choose our u and dv, remember that in our u-sub step, we would just have u and then take the derivative. We do something pretty similar. We're going to make this little rectangle here. We're going to put u and dv. I'm going to try to lower it real quick. dv. And then we have du and we have v. So we're going to choose something for u and dv. So those were the choices, just like in u-subs. So those will be the first two things we'll find. And then we'll automatically take the derivative to find du. And then we'll take an integral to find v. So that we have each of these four things. And then once we have these four things, it should be pretty easy to come up with a formula. But keep in mind that it's uv minus the integral of v du. And again, what we have to do is we have to choose between u and dv, as we'll see. And there's actually an acronym that works most of the time, maybe 95% of the time, for these questions in order to choose which one is a better u and which one is a better dv. So that's why people like integration by parts better, because the choice of u and dv is easier than the choice of u and a u-subs, because we have this acronym. I pronounce it liate. So liate. And again, this will help us choose between u and dv. L stands for log. So those are things like ln x or log base ax. Inverse trig is the I. So that's stuff like inverse tan, inverse sine, of course. A is algebraic. That's going to be one of your most common ones. That is going to be things like x plus 1 or x squared, or even dx itself. T is just regular trig, so no inverse, so sine, cosine, whatever. And then E is exponential. Exponential, meaning e to the x, maybe 4 to the x, things like that. So again, what this phrase tells us is to choose which functions are good to choose for u and which functions are good to choose for dv. Notice that in this process, what we're going to do again is we're going to write something for dv as part of the original, and we're going to take an integral. So it's good to have things that are easy to take the integral of for dv, which is why we like exponential to be our dv, because it's easy to take the integral of e to the x. Same thing with trig. It's pretty easy to take the integral of sine or cosine. log, it's a lot easier to take the derivative, so we like logs and inverse trig to be our u choice because we'll eventually take the derivative. So in this acronym, if it's closer to this side, that means that we're going to choose it for u, and if it's closer to this side, we're going to choose dv. And that's really the formula. Sort of a little bit of a confusing process, but as you'll see, it's the same thing over and over and over again. So we probably should just get straight to examples, and you'll see that this is a little bit clearer. But again, what we're going to do is we're going to form this little rectangle, u dv. We're going to choose u and dv based off liate, L-I-A-T-A, comparing u and dv. And then finally, once we do that, we're going to take the derivative of u, take the integral of v, and then we're going to form uv minus integral of v du, and then hopefully we'll be able to take the integral of v du afterwards. So let's see this in action. So let's erase the board here. Let's erase the board. We can put a little bit of hints on the board, so we can write liate in the corner here. Again, good u's are on this side, good dv's are on this side, as we'll see. We'll write the formula as well. The integral of u times dv is equal to uv minus the integral of v du. Basically, we're reversing u and dv. So in this case, we're going to start off with a fairly easy question. Let's start off with x times sine x. Actually, let's make it slightly harder. Let's make it x plus 2 times sine x times dx, of course. So this is our first question. So first off, we recognize that it's integration by parts because it's the product of two things that have nothing to do with each other, so they can't be a u sub. So what we're going to do is we're automatically going to form our little rectangle, u du v dv. So now is the choice part. Now is the part where we choose u and choose dv, and once we choose that, all of our choices are made for us, and that's great because I don't like free will. But let's make two choices at least. What should it be our u, and what should be our dv? So the dx is always part of the dv, so we can put dx right there. And then we have to choose, is u going to be x plus 2, or is u sine of x? So we have two things here. And what we do is we use liate. So x plus 2 is considered algebraic. It's an algebraic expression, so this is an A. Sine of x is considered trig, so we're going to write t for this. And then so notice that A is to the left of t in the acronym, so that means that x plus 2 will be a better u. Even if this were reversed, we want the one for u that is in the left side of the acronym. A is to the left side of t, so we're going to write x plus 2 here. So x plus 2 is going to be our u. That makes our v going to be sine of x because it's to the right of the acronym, because we have an algebraic versus a trig, algebraic and trig, and the phrase liate. So it's going to be sine x. And then just keep in mind that it's kind of confusing because you're going to take a derivative on one side, take an integral on this side. So sometimes people like to draw arrows. What's the integral of x plus 2? We're going to write that as the derivative of x plus 2. Sorry, we take the derivative of this side, integral of this side. So the derivative of x plus 2 is just dx. What's the integral of sine of x? Well, that's just going to be cosine. Let me move the v over here. So the integral of sine is negative cosine x. You do have to take an integral here. And now we're ready for the formula. So the formula is u times v. So we're going to x plus 2 times cosine x with a minus u times v minus the integral of v du. So it's going to be minus cosine x dx. So notice that the formula does have a minus, but a lot of times you incorporate or you introduce more minuses as you do the process. So we did introduce a minus when we were doing v, so these minuses will cancel and will become plus. But keep in mind that the integration by parts formula is a minus. So in this case, we're going to simplify a little bit. We're just going to put the minus, do that step real quick. That's going to be negative x plus 2 times cosine of x, and right here, and then I'll be plus the integral. Sorry, I'm writing it underneath here. Not very organized, but I think we'll be good to go. And again, integration by parts, just like with u subs, doesn't spit out the question or the answer automatically. You do have to integrate this thing further, but hopefully you'll know the integral by this step. What is the integral of cosine? Well, that's just sine. So in this case, the answer will be negative x plus 2 times cosine plus the antiderivative of this. So it's plus sine of x plus c. And that's the answer. So again, let me just recap this because this was a quite lengthy process. So you see something that's a product, so it's integration by parts. You're making two choices, one for u and one for dv. So you look at your two functions, and you just categorize them in the form of Lyautey. Is it log, inverse trig, algebraic, regular trig, or exponential? In this case, we have an algebraic and a trig. So algebraic is on the u side, trig is on the right side, so it's on the dv side. So that's where we place these two in their respective positions. For this u, we always take the derivative, so that's 1 times dx, just like with u subs. It's technically du over dx, and we bring over the dx. And then for sine of x, the antiderivative of sine of x is negative cosine of x, because the derivative of cosine x is negative sine x. Once you have this rectangle, you should go for the formula, uv minus the integral of v du. So it's u times v, that was this thing right here, minus the integral of v du, boom, boom. And then when we had this, we had minus minus, so this became plus. And so we have this guy right here. And once we have the step, once we carry out the integration by parts process, hopefully you know the antiderivative. We do know the antiderivative, and then we were done. So that's how a normal integration by parts question looks. Let's just do maybe 4 more examples so that we can get our feet wet in this process. Not the worst process in the world. Just know Lyautey, know the formula, know how the rectangle works, and then just take that final antiderivative. So let's do another one. So I'm going to erase this. I'm going to erase this now. So let's do something like the integral. Let's say, what do we got? Let's take ln x times dx. So integration by parts allows us to do a few famous integrals like ln of x. So we're going to do that here. It looks like we only have 2 functions here when we try to do our 1 function, because we have ln of x when we try to form our grid. But keep in mind that dx counts as algebraic. So here we're going to talk about Lyautey again. So what's ln? ln is natural log, that's log. So this is going to be a good choice for you because it's towards the left side. This is L. Let me make a better L here. And then again, dx counts as algebraic because it's like 1 times dx. Keep in mind that dx is algebraic in a lot of the cases, where your example of your algebraic is just dx by itself. So in this case, looks like we have an L and an A. Well, L and A are positioned in Lyautey like this. Towards the left are good choices for you. Towards the right are good choices for dv. So it looks like ln of x is going to be my u. Ln of x is going to be my u. What's going to be my dv? Well, it looks like it is going to be, I believe, let's say, what do we have for a dv? Just dx. The other thing, because it's closer towards the right side, because it's algebraic, dx. So then once you have this, again, all of your choices should be made for you. You don't have to think about anything, you just carry out the process. So what's the derivative of ln of x? That's going to be 1 over x. We're going to write times dx, because again, we bring that dx over like normal. So if you want, you can draw an arrow here. Then for our v equals, let's shift it over a little bit to leave a little bit of space so that we can sort of decipher this a little bit. When you have the dv, what you want to do is you want to take an integral. The integral of just 1 is x. So now we're going to perform the formula. U times b minus the integral of v du. So it's going to be ln of x times x. And we'll just write an x here. So u times v minus the integral of v du. X times 1 over x dx. So again, integration by parts, just carrying out the process doesn't give you the answer. You do have to do a further integral, but it looks like this integral is going to be fairly simple because these x's cancel very nicely. I'm going to put the x in the front because it's a little bit annoying where it is. So it's x times ln of x minus the integral of 1 dx. The integral of 1 is so easy that it's hard, but we already did it in the video. We actually already took the integral of just 1 dx. That's just minus x. The integral of 5 is 5x. The integral of just dx is just x. Then we put the uv still in the front, so it looks like we are done. So again, in these easier cases of integration by parts, it's not too bad, of course. Just keep in mind that dx counts as a, and then again, just do the process. uv minus the integral of v du. You form this rectangle. You have to choose between u and v. Those things that are on the left are good u's. These things on the right of the acronym are good dv's. For your u, you take a derivative. For your dv, you take an integral. Then you write uv minus the integral of v du. You might need to simplify to do this integral, but you have to do the integral eventually, and you just go for it. And that's that. So let's do a few more of these. by a few more. I mean, maybe several more, whatever your definition is. So let's do a famous integral that is also done by parts, and that's going to be inverse tan. So we're going to erase this. Inverse tan time. How exciting. Let's go for it. So we're going to do the integral of inverse tan instead. Going to be pretty similar. Looks like we have two things here. Dx, which counts as algebraic, and then we have inverse tangent x. Inverse tangent x, I believe, counts as inverse trig. That's why it's called inverse tangent. So inverse trig, I stands for inverse trig. I is still to the left of A, so it looks like my good choice for U is going to be inverse tan x, because again, the things on the left side of the acronym are good U's. So this is going to be inverse tan. And then we are going to have dv. dv is just going to be my dx here. I'm going to take the integral because it's the same as the previous one. V is just going to be x. How crazy. du, you got to know your derivatives, friends. Like, sometimes just the derivative of inverse tan just appears in the question. So just memorize your derivatives, memorize your antiderivatives. This one is 1 over 1 plus x squared times dx. Once you form the formula, and how did we do this? We chose u because u was inverse tan because it was towards the left side of the acronym. We chose dx, it was the right side of the acronym. We always take the integral of dv. We take the derivative of u, so that's what we did. And now we're ready to form the formula. So it's u times v, so it's going to be tan to the negative 1x times x. Again, I'm going to write it in the front just to make it a little bit prettier. And it looks like we have x over 1 plus x squared times du. V times du. Unfortunately, again, the integration by parts process doesn't give us the answer. So it looks like I have to do this integral. This is a dx, by the way. I have to do this integral. And what's the best way to do this integral? Well, it looks like it's going to be a u sub where the u is on the bottom. So once you get this new integral, crazy things can happen. Notice in this case, we have to do a second u sub, but it's not going to be too bad. Hopefully I can use the letter u and you're not going to confuse it with this. Just think of this as a totally new question. So in this case, u is equal to 1 plus x squared. Nice, lovely time to review u subs, of course. You take the derivative, du is equal to 2x dx. So I'm going to rewrite this because that's just in front of the integral. Then I'm going to start subbing in my u's just like normal. I substituted in one line at a time. So I chose this as my u so I can put u on the bottom. Why was this a good choice of u? Well, its derivative is sort of in the question, and that's why we got a good answer. Looks like we need to sub in x times dx, so we're going to solve for x dx. So x times dx, well, that's du over 2. So x times dx, hopefully you can read this, is du over 2. So instead of writing x dx, we sub that in. We're going to write du over 2, but we always like to take out our constant, so it's going to be this. Again, not the hardest u sub in the world. If you had this on your u sub quiz or test, you'd be like, oh, I can do this. Unfortunately, it's just nested within another question. But we are almost done. What we're going to do now is we're going to take the integral of this because we finished our u sub. We changed all the x's to u's, which is our goal. So it's going to be this minus 1/2. What's the integral of u? Well, that's just ln of u plus c. And then it looks like we have enough space just to write the answer. At the very end, we're going to replace our u with 1 plus x squared, and we are done. 1 plus x squared. Let's see if I can write it out. Looks like it's very messy in the end, but hopefully you can tell what we did. Again, we just carried out the integration by parts method, just like we did previously. uv minus the integral of v du. Liate, take the derivative of u, take the integral of dv, write the form uv minus the integral of v du. But unfortunately, when we have the integral of v du, we got to do a u sub to do that integral. So just keep in mind that that does happen. Again, when you have these integration by parts questions, it converts it to an easier integral, but the easier integral still doesn't have to be necessarily easy, unfortunately. So let's do a few more examples to see some things that might appear in these integration by parts questions. So let me just keep erasing and let's just keep going. Going to keep going, going to keep going. So a lot of times you're going to have some e to the x's. Let me rewrite this formula. U times v minus the integral of v du. So sometimes you're going to have some e to the x's. So let's try one of those. So it's going to be the integral of e to the 3x. Let's do e to the 4x actually, times x plus 2. So we're going to try to do this integral now. So notice that it is integration by parts because we have the product of this thing, and they're really unrelated. So now let's go for the formula. If you want, you can form my little rectangle. I like my rectangle. He is my friend. So when we have this, remember you're choosing two things, u and dv. Dx always goes with dv. So now we're just basically choosing between u and dv for the e to the 4x and x plus 2. So let's label each of these. E to the 4x, that's exponential. X plus 2, that's considered algebraic. So again, things that are on the left side of the acronym, the lia part of liate, are good choices for you. So that's why A is to the left side of E. So that means that x plus 2 will be a good choice for you. You wouldn't want x plus 2 in this dv spot because when you take the integral, it gets a little bit harder. To finish this out, what makes that dv? Well, dv will be towards the right of the acronym because of e to the x. So e to the 4x is going to be on this part of the acronym. So now we're ready to do take the derivative of this side, take the integral of this side. What's the derivative of x plus 2? That's easy, dx. Be careful about this guy right here though. The antiderivative of e to the 4x. This is what we were talking about, easy u subs, skipping easy u subs. If you want, you could u sub this on the side because you would let u be 4x. But if you know easy u subs, what happens is you just take the antiderivative of this function. So that's going to be e to the 4x. And then you multiply by the reciprocal of the derivative as opposed to just multiplying by the derivative of the inside function like the chain rule. Because you're taking an antiderivative. Again, we're taking an integral here. So instead of multiplying by 4, I'm going to be multiplying by 1/4. It's just a lot easier to skip that u sub if you can recognize that it's an easy u sub. So for example, the integral of cosine of 5x would be 1/5 times sine of 5x. The integral of e to the x over 2, that's 2 times e to the x over 2. You just flip the derivatives of the inside function. So again, this was a u sub technically, but we're u sub in our head, and that's why we encourage you to watch that u sub video, skipping the u subs and that AB integral review, just to save a little bit of time. But now, looks like we have the rectangle ready, so we can go for our formula here. So it's going to be u times b. I'm going to write the 1/4 in the front because I'm not a barbarian. So it's going to be 1/4 x plus 2 e to the 4x. I am a barbarian because I've seen I've run out of space. Keep in mind that there is a 1/4 e to the 4x still. 1/4 e to the 4x times dx. I'm going to take one step and I'm going to take out my constant because that's my best habit. That's why people respect me as a person, because I always take out my constants out of integrals. I feel like that makes life a little bit easier on everybody. So we're going to take out that constant 1/4 integral of e to the 4x times dx. So again, integration by parts gives you a new integral, and hopefully we can do this new integral. Well, this integral is a lot simpler than the one we started off with because e to the 4x is now by itself, so we can isolate him and hunt him down. What's the integral of e to the 4x? Again, it does require a u sub at least in your head. The antiderivative of e to the 4x, well, you just take the antiderivative of e to whatever, so it's e to whatever. Instead of multiplying by 4, we're going to multiply by 1/4 because again, we're taking an antiderivative. This is the skipping the easy u sub. So it's going to be minus 1/4 times 1/4. So this will eventually become 1/16. You don't have to do anything with the uv ever, just keep rewriting it. 1/4 x plus 2 e to the 4x. Finally, let's finish the question. Looks like it's going to be 1/4 x plus 2 e to the 4x minus 1/16 e to the 4x. We forgot a plus c, so remember the plus c, and that's what it. So again, just throughout these integration by parts methods, as you take the antiderivative of potentially the one that comes up with integral of v du, or even when you choose dv and you have to take its integral, you might have to do a u sub just to do that. So just be wary of that. So let's do a few more examples. Let's try to do a harder examples, maybe not harder examples, maybe more annoying examples is the better word. So let me erase this. Let me erase this guy, erase this, erase this. There's something called the tabular method that would help in the next question, but I feel like just regular integration by parts should be sufficient. So let's try to erase this without liate in the formula so that we can practice just trying to come up with it for ourselves. This time we're going to do the integral of x squared times, let's say, cosine x. So this is going to be the integral that I want. So it is parts because x squared and cosine x doesn't have anything to do with each other. Keep in mind that some products are u subs. For example, if this were cosine of x cubed times x squared, that would probably be a u sub because u would be x cubed because its derivative is sort of x squared. But in this case, because they're not very related, it has to be integration by parts. So I form the thing, u du v dv. So what's u? Well, u is going to be, we have to distinguish between x squared and cosine x. X squared is algebraic, which is a polynomial. Cosine x is trig, not really a polynomial, a monomial, I guess. Cosine of x is going to be trig. And then remember the phrase viate, if you're towards the left, you are going to be the u. If you're towards the right, you're going to be the dv. So in this case, because a is to the left of t, and the phrase viate, u is going to be x squared, du is going to be cosine x dx. So cosine x dx. Then once you choose these, just follow the process. The derivative of x squared is 2x times dx. What's the integral of cosine? Well, that's going to just be sine x. We are good to go. So let's just write the formula down. The formula is u times v minus the integral of v du. So u times v looks like it's x squared times sine x minus, because the formula is uv, minus the integral of v du. So it's v sine x times dx, and I'm going to take out my 2 because again, I like taking out my constants. So now I have my easier integral, but unfortunately it looks like it's still a product. So you know what that means? We have to do this process all over again for this guy right here. So that happens sometimes. Every time you have something times cosine x or something times e to the x and you have something with the power goes down by 1 every single time. So unfortunately we do have to do this again. But maybe that's the gift of life here, where we get to do integration by parts again. So what I'm going to do is I'm going to just do this integral on the side. The integral of x times sine x dx. Shouldn't be too bad. And then once we find this integral, we're going to substitute in for this. So let's leave some space here, and our final answer will be somewhere in the middle. How crazy. But let's just form u and v real quick. Du and dv. So not much has changed, except it's just slightly easier. So what's the u? This is a is algebraic, that's what x is. Sine of x is certainly trig. So again, the x is going to be the u, the trig is going to be the dv. So u is going to be x, du is going to be dx, that's lovely because it got a little bit easier. Sine of x is going to be in this slot. And then how do you find v? You take the integral. Keep in mind that's minus cosine of x because the derivative of minus cosine of x is sine of x. So now what we're going to do is we're going to do uv minus integral of v du one more time. So it's going to be this times this, where I'm going to put the negative in the front. Then it's going to be minus the integral of v du, which is just dx. But again, the formula is minus, but sometimes when you take antiderivatives of the dv to v step, you introduce minuses. So in this case, we have minus minus, so this becomes plus. Let me just change that to a plus. And now we're going to do this integral. This little baby integral won't require additional u sub, thankfully. It won't require another integration by parts. So this is minus x times cosine of x plus sine x. So that's this easier integral. This is the integral of sine of x times dx. So what we're going to do is we're going to take this guy and replace right there. So it'll be minus 2 times this quantity, and then we're done. So the final answer is going to be x squared times sine x. And we had to do this harder integral on the side. It was another integration by parts. How crazy. A nested integration by parts where you do one, then you do another. So it's going to be minus 2. And if you want to be lazy, you can just put all of this in parentheses. If you're not feeling super lazy, you can distribute. Hopefully I have enough room here. Minus x cosine of x. We'll put a dot here. And then we'll erase this, put plus sine of x. And then finally, let's write plus c right there. So again, this integration by parts method, some people don't like because it doesn't give you the answer immediately. Sometimes you have to use sub, as we saw. Sometimes you have to do another integration by parts. But again, the process isn't too bad. You just slowly go through your work and you should be fine. So as a nice special treat, let's do the hardest integral, what I call the add back integral. I don't think it actually appears on AP exams, but you never know. So what we're going to do is we are going to do it because we like a nice little treat to end the video. So this is going to be the hardest example. Sometimes these appear on college calculus exams just to spice things up. So we're going to do the integral of cosine of x times e to the 2x. And it's going to be quite difficult, but I believe in us and we are strong people. So we're going to start this process by forming the rectangle. I need to write a little bit small. That's a little bit of a warning that this question is going to be hard, but we can do it. So cosine of x is considered trig. E to the 2x is considered exponential. So trig is to the left of exponential. So that means that u should be cosine of x. And that means dv is going to be e to the 2x dx. Then what I do is I'm going to do my normal derivative of the u, integral of dv. Derivative of cosine of x is minus sine x dx, because we bring the dx over. Then, hopefully I can divide this in a space. We have to do the integral of e to the 2x, but again, these are these easy chain rules that you should do in your head. Instead of multiplying by the derivative of the inside function like a regular chain rule, because we're taking the antiderivative, we are going to multiply by the reciprocal of the derivative. So instead of e to the 2x, which is the antiderivative of just e to something, it'll be e to the 2x times 1/2. So now let's write this answer. So it looks like when we do u times v minus v du, it'll be this times this, it'll be 1/2 e to the 2x times cosine of x. And then the formula is minus the integral of v du. So the v du is going to be 1/2. I always like to take out my constants. E to the 2x times sine of x dx. Notice that du is negative, so again, you're introducing negatives, so the formula is negative, negative, but instead of writing negative sine x, I'm going to let the negatives cancel each other out, so I'm going to write positive here. But again, the formula is negative, you have a negative here, negative times negative is a positive. But it doesn't look like we did a lot of work, because if you notice the original, and you notice this, it's not simpler, unfortunately. We have e to the 2x, and we have sine instead. So what I'm going to do is, I'm just going to blindly do integration by parts again. I'm going to take this guy right here and just perform integration by parts. So what I'm going to do is I'm going to do the integral of sine of x times e to the 2x times dx. And then I'm going to do integration by parts on this because I have no idea what else to do. So it's going to be the same sort of process. U is going to be the sine x because we're going to have t in exponential again. Sine x. Our dv looks like our e to the 2x. Our dv is still going to be e to the 2x. And just keep in mind that, again, as we take that integral, it's going to be 1/2 e to the 2x. V will be 1/2 e to the 2x, so we're skipping that easy u sub. Then, to take the derivative of sine of x to find our du, that's going to be cosine of x. Not going to complain there. So let's try to find uv minus integral of v du for this easier integral, or not this easier integral, our second integral. So it's going to be sine of x times 1/2 e to the 2x minus the integral of v du, so it's 1/2 cosine x times, let's see, what do we have? Minus 1/2 cosine of x times e to the 2x. Again, I took out my constant. In this case, we had no negatives, so the formula holds uv minus v du, so then we have this. So again, this first integral was equal to this, and then we took this integration by parts again. So this quantity right here is this guy right here. And it doesn't look like we made any progress because we got back to the original, but we actually wanted to get back to the original. So let's write our findings in this case. What we have is this original integral. So let me try to have enough space. This is going to be quite intimidating. But what we're going to do is we're going to rewrite this original integral because that's the question. Cosine of x minus e to the 2x times dx. Then it's equal to this quantity right here, 1/2 e to the 2x times cosine x. My board is too small, but I'm going to write plus 1/2 times all of this. There's no way I have enough space, so we'll write it underneath here, plus 1/2 times 1/2 sine x e to the 2x, sine x e to the 2x. I'm just very intimidated by the lack of space here, minus 1/2 the integral of, man, this is going to be really bad. Let me try to erase this and let me try to rewrite it a little bit nicer. Hopefully what you see is that we did uv du dv to form these two things, so I don't think I need the uv du dv, so I'm going to erase it so that we have more space. If you need to copy this down and pause the video, but I need all the space in the world for this question, as you can tell. So I'm going to erase this guy right here, unfortunately. So again, we did a liate, we did an integration by parts to get this thing. And what we're going to do is we're going to take this original integral, and again, we're going to replace this guy into our integral. How fun of a process is this really? So we're going to take this guy right here. So this is the original integral of cosine of x times e to the 2x times dx. Then we're going to write this guy right here, 1/2 sine of x. Now we have enough space. I'm writing the wrong thing though, because this integral is originally this. So let's write this. I don't even know what I'm doing anymore. E to the 2x times cosine of x. We're going to write plus 1/2. And then again, we had to do this easier integral with another integration by parts, and we got this. So we're going to write this instead. 1/2 sine of x times e to the 2x minus 1/2 integral of cosine of x e to the 2x times dx. Wowza, wowza, wowza. So again, we have this harder integral. We did integration by parts. In order to do this integration by parts, we saw that this integral was equal to this quantity. So we replace this integral right here with the 1/2 multiplying it with this quantity. So what I'm going to do is I don't want to rewrite this. So I'm going to distribute the 1/2. So it looks like this becomes 1/4. And then this becomes the 1/2 times this 1/2 will be negative 1/4. So it'll be negative 1/4. So basically you might be asking, why in the world are you doing this? Are you trying to torture yourself? Well, we actually got to the end of the question, because notice what we did is we got back the original thing. So all I'm going to do is I'm going to take this guy and add it to the other side. And while this is a difficult quantity, if you have something plus 1/4 of that something, what you're going to end up with is 5/4 of that something. So when we add this 1/4 over, it's going to be 5/4 times our original thing, the integral of cosine of x times e to the 2x times dx. And what will be left on this side? Well, it looks like it's going to be just this thing and this thing, because we brought over the 1/4, and 1/4 plus 4/4, which is just 1, is equal to 5/4. So it's going to be 1/2 e to the 2x times cosine of x plus 1/4 sine of x times e to the 2x. And again, how do you isolate this last thing? How do you isolate our very integral? Well, at the very end, all we're going to do is multiply by 5/4. And notice that when we multiply by, or 4/5 to get rid of the 5/4, and when we do that, everything goes away. We are left with what we want. We'll write plus c at the very corner, and that's how you do it. So that's the beast of the question. That is the add back question. So let me just remind you what we did. We did liate. When we did the dv to v step, we were careful with an easy u sub. We formed liate, u times v minus the integral of v to u. There were some minus actions, but we were okay with that. Then we got an integral that didn't seem any easier than the other. So we blindly did integration by parts again, and we ended up getting this. So what we did is we replaced these two things into our integral, and what we got is that our original integral was equal to the uv of its integration by parts plus 1/2 times all of this, which ended up being this once you distributed the 1/2. Finally, why we called it the add back is we noticed we got back the original thing we wanted to find on the other side of the equation with a key minus, so we can take it and add it back to the other side. When you have 1 of something plus 1/4 of something, that'll be 5/4 of something. So we have a 5/4 here is equal to whatever was remaining on this side. And then finally, to isolate, we multiplied by 4/5, and that was the answer. Whew. Again, this is a beast of a question. You might not expect it on the AP exam. What I would suggest if you were in BC is to really focus on the normal level questions. U times V minus the integral of V du. Let liate be your friend as well. It helps you choose the U's and the DV's. Logarithm, inverse trig, algebraic, trig, exponential, U's on this side, DV's on this side. If you want, for more practice, consider watching our Girls Teach Calculus video where one of my former students practices some of these questions. She does basic questions, and then she does questions where the second integral is a u sub, the second integral is another part, the second integral is the add back at the very end. Again, if you're a historian of the AP exam, you'll know that sometimes they don't ask straight up integration by parts questions. They usually ask it in a general way with a table. So watch our next video, which is going to be on definite integration by parts and also general integration by parts for practice on those. But thanks again for joining me as we had fun with this add back, as we learn integration by parts. Hope to see you next time, and thanks again for watching.